The learning objectives of this chapter are to know the ECDIS configuration on a vessel and carriage requirements. These training modules are designed to teach navigating officers the generic principles and operational use of electronic charts on an ECDIS. The objective of the training is to enable ECDIS to be used in a safe and competent manner. Information can be fed into an ECDIS system from several different sources. The primary use of ECDIS is to store electronic charts on which the ship's position is displayed. Some ECDIS devices can also store and display digital publications, such as pilot books, list of lights, and list of radio signals. Some ECDIS devices are also capable of displaying information from the vessel's machinery, such as main engine, rudder, and thruster. An ECDIS could have numerous other connections allowing inputs from several other devices, such as an anemometer, echo sounder, and AIS receiver. In 2002, a revision to the existing regulations stated that an approved ECDIS device is acceptable under SOLAS Chapter 5 Regulation 19 for the chart carriage requirements. This means an ECDIS must be capable of storing electronic charts that are equivalent to full folios of paper charts for the intended voyage. Many years ago, various types of electronic charts were made to assist plotting and recording of large amounts of data. These were often associated with specialized operations, such as oil and gas exploration. Charts were viewed on devices called chart plotters or electronic chart systems. The chart plotter, or ECS, still exists today and is used on many types of vessels. It should, however, not be mistaken for a fully type-approved ECDIS. Merchant vessels started using electronic chart systems in the 1970s, causing a demand for worldwide electronic chart coverage. From 2012 onwards, there has been a rolling program to have new and existing vessels compulsorily fitted with ECDIS. ECDIS manufacturers get product approval under standards laid down by the International Hydrographic Office, focusing on the hydrographic elements, and the International Maritime Organization, focusing on the functionality of ECDIS. IMO introduce revisions to the standards when there are increased or changed requirements. When manufacturers follow the same standard, operators should find it easier to use different makes of ECDIS. Some advantages of ECDIS include the following. It is capable of displaying lots of information, recording voyage data. It has tremendous flexibility when it comes to file handling. It is space-saving compared to storing folios of paper charts, and saves lots of time chart correcting. A major disadvantage of ECDIS is the operator becoming fixated with the display, thinking everything they see is correct, and not maintaining other watch-keeping duties to support the navigation. Other disadvantages include: the software can be complicated to use. The chart display size is limited by the size of viewing monitor fitted, and when compared to a paper chart, it can appear small. The system can be prone to vibration damage, and most importantly, the operator can go into information overload, making it difficult to see what is important. The display size can affect the operator's situation awareness, particularly on a fast-moving vessel. When on passage at high speed, the small amount of chart displayed on the monitor means the operator may not be aware till it is too late of dangerously close objects ahead of the vessel. Under STCW 95 requirements, Table A2/1, a navigating officer is required to have a thorough knowledge of and ability to use navigational charts and publications such as sailing directions, tide tables, notices to mariners, navigational warnings, and ship routing information. The 2010 Manila Amendments make it mandatory for all navigating officers to be competent in the use of ECDIS to maintain the safety of navigation. There are additional duties for masters and chief officers to manage ECDIS. The presence of ECDIS does not relieve the watchkeeping officer from their normal watchkeeping duties to maintain the safety of the vessel. If navigation is totally or partly performed on ECDIS, there has to be an independent backup system available. There are two main reasons for this. If the ECDIS fails, IMO require the backup to be instantly available to ensure that failure does not result in a critical situation. The backup should provide for safe navigation for the remaining part of the voyage. It should be capable of geographic representation, with route monitoring and voyage data recording as the main ECDIS would. The ECDIS has to be independently connected to the emergency power supply in case of mains power failure. It should continue operating normally for at least 45 seconds to allow an uninterrupted switchover to emergency power. Let's summarize what you have learned in this chapter. An ECDIS displays other information apart from electronic charts. It's acceptable under SOLAS chart carriage requirements. we've learnt that an ECS is not an approved ECDIS. Also, ECDIS is approved in accordance with IMO and IHO standards. And finally, that the main ECDIS should be backed up with a secondary device.